class. In today's lesson, we're going to be looking at sketching using factorization. The learning intention is to know the steps for sketching a quadratic in the form of y is equal to x squared plus bx plus c, to understand that quadratic graphs could either have 0, 1, or 2 x-intercepts, to know how to use the factorization technique to determine the x-intercepts, and lastly, to know how to use symmetry to locate the turning point once the x-intercepts are known. So I want to go through again that the main three features that you need to be able to identify when drawing a parabola will be the x-intercepts, your y-intercept, as well as turning point. Notice over here I've actually included intercepts as a plural in brackets because it could either have 0 intercepts, 1 intercepts, or 2 intercepts as shown in my diagram on the right hand side over here. And if you wanted to find the number of solutions for any for a given quadratic equation, we can readily identify this based on our current understanding of transformations and when it's expressed in the turning point form. So for instance, as you can see, if it's going to be vertically shifted up very high, well, obviously this would make sense that you're not going to really get any x-intercepts at all. As you can see over here, if your k value is equal to 0, that just means that there is no vertical translation. It's just moving left to right. So therefore, the parabola is only going to be just touching the x-axis just once. So therefore, only one x-intercept. And therefore, if you've got a negative value, because it's shifted down, this would imply that you would technically therefore have 2 x-intercepts as a result. Now, if you were to try to find out how many x-intercepts are, not to find it out, but to find out the number of x-intercepts, what you could do is you could actually calculate what the discriminant is if it was expressed in the standard form. So this is the standard form over here, and this is the formula that you would use to actually calculate what the discriminant. We're going to go into a lot more detail as it is for future lessons. So don't be too concerned of yourself. But as you can see, I really want you to just see that the value of b, you just substitute that in. Your value of A and C, substitute those in, and depending on what value it is, then you can actually make a judgment to say, does this have 0 x-intercepts, 2 x-intercepts, or 1 x-intercept in this case over here. As you may recall, there are a number of ways that you could actually use to calculate your x-intercepts. You could use the square roots, factorize and apply null factor law, complete the square, as well as using the quadratic formula. In the previous lessons, we looked at the two main methods, so you were using the square roots and factorizing. And it's really critical that you guys still retain this knowledge, otherwise it might be a bit difficult for you to actually find your x-intercepts, okay? To do this, remember, once we factorize it, then we could use the null factor law. And we said the null factor law was saying that any terms that are multiplied together and equals to 0, this would imply that either this term over here is equal to 0, either b is equal to 0, alternatively, both of them are equal to 0. As I've already said, class, it is really important that you still recall knowledge on how to actually factorize and solve for the x-intercepts. So I'm going to give you these questions to do right now. If you are unable to actually successfully complete them and you got most of these questions wrong, then I probably recommend it might be better to stop watching this video and watch the other video so that you can quickly catch up. But if you've answered these questions successfully for the very first one, remember what we need to do was we need to equate each factor to 0 and then solve for x, okay? So in this case over here, I've equated both of them to 0, and now to rearrange, just use inverse operations. Therefore, x is going to equal to -1 or x is equal to +2. For the very next one over here, again, this is the same thing as writing brackets. So x is equal to 0, x minus 3 is equal to 0, rearrange, therefore these are your solutions. And for the very last one, x is also going to be equal to 0 and x is going to equal to -2. For the second question over here, you need to factorize it. So for the first one, this is a very simple quadratic equation. So all we do is just locate and find out what is your highest common factor and bring that outside. In this case, this is going to be your final answer. In this case over here, it doesn't actually ask you to solve for x-intercepts, just simply factorize. For the second equation over here, you need to use a product sum method. So find out two factors multiplied with each other gives you -8, but gives you a +2. In this case over here, it's going to be +4 and -2. The last one over here, find out two factors. So in this case, two numbers that will give you +16, but adds up to -8. That's going to be -4. So it's going to be x minus 4, x minus 4. Alternatively, you could also rewrite this as x minus 4 whole squared as well. And for the very last example, I'm hoping you guys can recognize that this is a difference of perfect square. So therefore, your answer would be y is equal to x plus 5, x minus 5. So now we're going to be looking at the y-intercept. So remember, just a quick revision. We calculate the y-intercept by substituting x is equal to 0 and then solving for what y is. But when it's in the standard form, your y-intercept is readily given by the value of c over here, okay? And as shown by this diagram, this is your value of c. So as you can see over here, your y-intercept is equal to 3. Yeah, technically, as I said, you need to be stating the coordinates. So you should always be labeling as 0, 3 over here as well. Have a go at answering these questions over here. I want you to find the y-intercepts and then we'll go over the answers after 2 minutes. So for the very first one, it might not appear obvious, but it's also kind of written in the standard form as well. So again, what we need to do is sub x is equal to 0, and therefore you'd see that your y-intercept is equal to 0, and that's also reflected by this value here. Always give your answers in coordinate form. And for the next one over here, it's going to equal to -8, but to show full working out, which isn't really necessary at all, it'll be 0,8. For the next one, it's going to be 0,16. We can really tell that by this number over here. And for the last one, it's going to be 0,-25. And for the last thing that I want to talk about, and this is probably the main part as well, other than actually sketching, but how do you find the turning point, okay? We're mainly going to be looking at equations today that are expressed in the standard form. And when it's expressed in the standard form, there are two ways to do it. The first method is a bit more logical, but once you've already determined what your x-intercepts are, your turning point or your axis of symmetry, okay, is always going to be the value that's in between your two x-intercepts, okay? So in this case over here, this is a -3, -1. Well, what's the number in between? That's -2, okay? So to do this algebraically, you just add those two numbers together, divide by 2. That's how you find the midpoint between two numbers. So that's the more logical way, and that's the way that the textbook wants you to use for this particular exercise. But I want to show you a shortcut method, and it's a method that I prefer myself, okay? So to find out your turning point, what you'll do is, this means your x value turning point, you substitute the values -b and divide it by +2a. And if you do this, this will give you the x value of turning point, and then substitute that in to the equation to find out what is the y value of turning point, okay? And I want to show you two methods, and I'll show you why it is that the second method is a lot more effective than the first method. Let's now use an example, and I'll show you how you could actually find out the turning point using both of these methods. So as I said, for the very first method, what you need to do is find the midpoint between the two x-intercepts. So you need to know the x-intercepts before you can actually find your turning point when it's given in the standard form. So we've already factorized this from our previous question. We said that was equal to x plus 4, x minus 2. And then use a null factor law to solve for x, okay? So therefore, x plus 4 is equal to 0, x minus 2 is equal to 0. Therefore, x is equal to -4 and +2. Now, once you found out what your x-intercepts are, to find the midpoint, you add these values together and divide by 2. So if I've done that, then it's going to give me -1. So that's the x value of your turning point. Now, to find out the y value, because you write a turning point as a pair of coordinates, x and y, we sub -1 into the OG equation, the original equation, and then solve for y. So if I've done that, then this is what I'd get. Chuck this in the calculator. Therefore, you're going to get y is equal to -5. And now we'll write the x and y coordinates together for your turning point. Therefore, your turning point is equal to 1, -5. So this makes sense. This is the most logical way. But I'm going to show you another method now, okay? And this is the method that I personally prefer. All we need to do is that when it's given in the standard form, we just basically use substitution to find out your x value turning point. So b in this case is equal to +2, and a is equal to 1 in this case, because that's the coefficient in front of x squared. So I substitute the values in, and then I'll just simplify. What's -2 divided by 2? Well, that's going to equal to -1 in this case, okay? Now we substitute -1 in again, and notice that in this case, you're still going to arrive to the exact same answer, and I prefer this method. I want you guys to now closely examine the two differences between these two methods of here, and I want you to tell me, why do you think I strongly encourage you to use the second method as opposed to the first method? What makes the second method, I suppose, better than the first method? Now, if you guys have identified this carefully, you can see that the first method kind of relies on you to find out what your x-intercepts are successfully. So that requires you to be able to factorize properly, and that's how you're going to get the turning point. If you can't get that correct, then obviously your turning point would be incorrect based on your x-intercept values. However, the second method doesn't, even if you do screw up your x-intercepts, you can still find out what your turning point is successfully, okay? And it's much more straightforward. So as I said, I prefer using the second method because the first method relies on you to successfully, that's the key word over here, find the x-intercepts and factorize it properly, whereas the second method more straightforward as it involves just direct substitution, okay? So I want you to have a go using the second method to find out what is the turning point for the following quadratic equation. It looks a bit more intimidating, I know, because it's a non-MONIC, but have a go and we'll compare our answers together. If you guys have done this successfully, your negative b value is equal to, in this case, will be negative 18. A is equal to 3. Substitute those values in. Negative 18 divided by 6, in this case over here, that's equal to negative 3. So that's your x value of turning point. Substitute that into the OG equation. Therefore, if you put this all into a calculator, you're going to get y is equal to negative 3 as well. Coincidentally, therefore, this is going to be equal to your turning point. Now, I want you to quickly pause the video right now so you can answer these questions over here. So question 7, answer these 6 questions, and then we'll go on to the next topic, okay? Sweet. So the next thing we're going to be looking at now is sketching parabolas. So in order to sketch the parabolas, we've pretty much had to find the values of your x-intercept, your y-intercept, and turning point. That's the reason why we looked at those examples. So I'm going to show you in total 4 examples, and then I'll get you to do one question together before I end today's video. So the very first one, we're going to be looking at a very simple MONIC binomial quadratic equation, okay? So in this case, if you x squared minus 2x, to find out your x-intercepts, we're going to factorize it, equate it to 0, use null factor law. So if I do this, x is the highest common factor, therefore take x outside, and now I'll use a null factor. Therefore, x is equal to 0, and x minus 2 is equal to 0. Solve for x. Therefore, these are your x-intercepts here. And notice I've also written this in coordinate form. Please do this, okay? Your y-intercept, in this case over here, notice that this is written in the standard form. Your value of c is equal to 0, but just to show proper working out, just to support it, y is equal to 0, as you can see here. And for the turning point, I'm using the second method again. So your b value is negative 2. 2 negatives will make a positive, okay? So positive 2 divided by positive 2, that's going to give you positive 1 as an answer. We'll sub that into the equation to find the y value. And therefore, this would give you negative 1 as an answer. And therefore, you write this as your turning point. So therefore, if I plot this, I'm going to indicate the 3 coordinates that I do know. I'm also going to therefore now draw a parabola that goes in between it. And lastly, please make sure that you are including the actual coordinates when you're drawing. So please include the x-intercepts, the y-intercepts, as well as your turning point. So these are the common mistakes that I often see over here. So I often see students draw very ugly or asymmetric parabolas. Remember that a parabola is symmetrical. So if your parabola doesn't look symmetrical at all, then I am going to be deducting some marks. So that's an example over there. Another thing that you will lose marks on is that you're not labeling your x and y intercepts. So notice for this Cartesian plane over here, you're not writing y and x on your axis at all. And lastly, you're not including coordinates for all intercepts and your turning point, okay? So if you do this, you will incur a 0.5 mark deduction for each of these mistakes over here, okay? So please don't do this because that's just 3 marks that you're giving up, okay? In the second example that we're going to be looking at, this is an example that I would want you to be able to do successfully by the end of the video, hopefully. So it's a quadratic trinomial, okay? So we're going to go through the process of sketching this. First, let's find out what your x-intercepts are going to be. So we're going to factorize this to find out your x-intercepts. So I'm using the product sum method. In this case over here, your 2 factors is going to be equal to -5 and -1. If you've done this, we'll use the null factor law to equate to each factor to 0. And therefore, if you rearrange it, x will equal to +5 and x will equal to +1. And I'm rereading this in my coordinate form. So I've already done the x-intercepts. To find out my y-intercept, it's going to be the value of c because it's in the standard form. So therefore, you can write y is therefore equal to 0,5. But I'm just going to show you full working out regardless. Do you need to show the full working out when you're doing this on a test? No, not for the y-intercepts, but for everything else, then yes, you do need to, okay? And to find out your turning point, your b is equal to -6, and therefore, because there's a negative sign here already, two negatives will make a positive. So it'll be +6 divided by 2. That will give you +3. We'll now find the y value of the turning point by substituting that value in. And therefore, if you do this directly into a calculator, you're going to get -4 as an answer. So now I've calculated my y-intercepts, my turning point. So now I'm going to graph this, okay? So I'll plot the points first onto my Cartesian plane. These are my coordinates over here. I'll now draw a curve that connects each of these points. And the last thing that I need to do is include coordinates. So therefore, I've included the coordinates as shown over here. Now, for the very third example, it's very similar to this one over here. You're still using the product sum method, but it's a bit different because I'm hoping that you guys can readily identify that this is a perfect square, okay? So therefore, if I was to factorize this, it's going to be x plus 3, x plus 3. Alternatively, you could write this as x plus 3 whole squared is equal to 0, okay? So in this case over here, equate them to 0. Therefore, x is going to equal to -3. And because, remember, these factors are the same, that just implies that you're only going to have one x-intercept. And this will always be the case when you do have a perfect square, okay? So therefore, write this as a coordinate form. So I've already calculated my x-intercept. Your y-intercept is going to be this value here. But again, I'm just showing full working out. I've done the y-intercepts. I now find my turning point. So therefore, negative b is equal to -6. -6 divided by 2 is equal to -3. Find your y value by substituting that in. Y is equal to 0. And that is my turning point. I will now plot this, and therefore this is what it would look like. And for my very last example, this is now going to be a difference of perfect square. So I will now factorize this. Now notice over here, I've given you an example deliberately that doesn't appear to be a perfect square because that doesn't appear like a perfect square. But remember, you could always express this as a surd. So therefore, if you did this successfully, then this is what it would look like in the factorized form. And therefore equate each of these to 0 and solve for them. Therefore, x is going to equal to positive as well as -√10. So you've got two x-intercepts over here. And you can already tell based on this already that because x squared is like this already, that -10 means you're vertically translating that down, okay? So therefore, because you're translating down, you will have two x-intercepts. Your y-intercept is equal to -10, and your turning point is going to therefore be 0, 10, okay? Because you could also, if you could recognize this, that's the same thing as writing y is equal to x minus 0 whole squared minus 10, and now that's kind of like in the turning point form. Therefore, your turning point is equal to 0, -10, okay? But if you were to use the method I was showing you, then this is how you would do it. And again, same answer. Therefore, this is what your graph would look like. This is the only question that I want you to do right now. So please have a go of answering this question, and then we'll compare our answers after 5 minutes. So the first thing that we're going to do is we're going to find out what your x-intercepts are. So let's factorize this using the product sum method. So what two numbers multiply each other gives you a +7 but a -8. That's going to be -7, -1. So therefore, this is what my factorized equation would look like. And after I substitute y is equal to 0. We'll now equate each of these factors to 0. And therefore rearrange to solve for x. X is going to equal to +1 and x is equal to +7. And always write this in coordinate form. Once I've done that, I'll now find my y-intercept. And your y-intercept is always going to be the value of c. And therefore, y is going to equal to 0, 7, okay? To find out my turning point, your b value in this case is -8. So negative with a -8 is going to make a +8. So +8 divided by 2 is going to give you +4 as an answer. We'll substitute that in, and therefore your corresponding y value is going to be -9. So your turning point is going to be 4, that should be -9 over here. That's a typo. And therefore, the question doesn't actually ask you, but because I can't test that using Edpuzzle, this is what your graph would look like if you were to actually plot it, okay? By now, I'm hoping that you should be able to understand most of the things that I've covered in today's lesson, okay? So again, just a quick summary. The main things is like to find x-intercepts, we just factorize and solve. For y-intercepts, it's always going to be the value of c when it's expressed in the standard form. There's two ways to find out your turning point, but I prefer you to use this particular formula over here to find out your x value turning point and then substitute in to find the y value. And when you're graphing, make sure that you do have attention to detail and include all intercepts in coordinate form and label your axis as well. So please have a go of answering these questions over here. Now it does appear that I am giving you a lot of questions, but I've deliberately halved the questions, so there isn't too much, but you do need to do a lot of these so that you are getting into the routine, okay? So answer questions 1 all the way to 16. You are skipping from questions 10 to 15 over here. So have a go with these questions over here. And question 16 is more of an extension question. You don't have to do this at all, but if you can do this, then you're putting yourself at a really good position, particularly when we're doing the CAT, okay? So hopefully you guys are able to meet the success criteria of today's video. I hope to see you guys again in the next video. Bye.